Good day. So in this video, I'm going to give you some tips on how to answer functions in an exam. So to do that, I've gotten some questions from the question papers, one from a parabola and a straight line, and the other one an exponential function, and another one also a hyperbola. So whilst we're answering this, I'll be giving you some tips on how to answer these and how it can be asked in an exam, and giving you also different methods that you can use to answer functions. So yeah, I know exactly that after this lesson, you will not be worried again with functions. So functions are quite easy. And when you see them in the exam, you should score all full marks. And there's actually a lot of marks on functions in paper one. So yeah, without wasting time, let's get into it. We're going to look at the examples. So the first example will be a parabola and a straight line. So let's just jump into it. Now, so in this first example, we are given the function of x is equal to x minus 4 squared minus 9. And we can see that pink graph, and that is a happy face parabola. And we are also given the function g. And that function is a straight line, and also the coordinates a, b, c, d, and e. And we can see that a and b, they are the x-intercepts, and c is the y-intercept, and c is a common point for g and f. And also e is the turning point of the parabola. So the first question, we are asked to write down the coordinates of e, which is the turning point. Now, if you look carefully, we are given the equation of the parabola in a format which we call the turning point format. So this is the equation, x minus 4 squared minus 9. So this equation, it's in a turning point format, which is like f of x is equal to a bracket x minus p bracket squared, then plus a q. So if you remember very well, we said that if you're given an equation in this turning point format, your coordinates of the turning point, they're just p and q. So p and q are the coordinates of the turning point. So in this case, we just read out the values, and this is your p, and it's a positive 4 because there is a negative already, and also y is negative 9. So the x coordinate, which is the point e, the x coordinate of that turning point will be a positive 4, and the y coordinate will be negative 9. So that will be the coordinates. So that is here, the coordinates of e are 4 and negative 9, and that is quite easy. So now let's suppose you were given this equation in expanded format. So let's say it was y is equal to x squared minus 8x plus 7. So now this is a format of y is equal to ax squared plus bx then plus a c. So if you're given in this format, let's say you're asked again to find the coordinates of e. So to find the coordinates of e, the turning point, there are two methods. You can use calculus, but I'm not going to use calculus. The method that you use, you have to know that the x coordinate of the turning point, so the x coordinate of e, is always calculated by the formula minus b over 2a. So in this case, that will be your minus b, it's a minus bracket minus 8 bracket, then divided by 2 times a, which is in this case a 1, and that gives you a 4. So once you have got the x coordinate of the turning point, you can substitute that 4 back into this equation. And once you substitute it, you realize that you get a negative 9. So this is another way of also getting the turning point. So let me know what you think. Now let's move on to the second part of the question. Now, in the second part, the B, we are asked to calculate the coordinates of A. And as you can see from the diagram, the coordinates of A is the x-intercept. So that is the x-intercept. So when you solve for this, you should expect two values because there are two x-intercepts, that is an a and a b. So remember, at the x-intercept, to find the coordinate of the x-intercept, we let y is equal to 0. And we have still our function f of x is equal to, in a bracket, x minus 4 squared minus a 9. So our y, this f of x can be called y. So 0 is equal to, in a bracket, x minus 4 bracket squared minus 9. Then, yeah, some students would prefer to expand this. That is fine. But in this case, I'm not going to expand it. I'm going to show you two methods. One we can expand and one we're not going to expand. So you just bring the 9 this side. The 9 will be equal to x minus 4, then in a bracket squared. Then you just find the square root of 9 is equal to x minus 4. And the square root of 9 is a plus minus 3. So that will be equal to x minus 4. Once you have that, you can split it and you can say x minus 4 is equal to plus 3, or x minus 4 is equal to minus 3. So we're just splitting the plus and minus. So then x can be equal to 7, and also x is equal to positive 1. So we have now the coordinates of a and b, but we are asked only to calculate for a. So that will be 1 and 0. That will be the coordinates. Remember to put a 0 for the coordinates. So if you had expanded that, some students would expand, and then they would get x squared minus 8x plus a 7 is equal to 0. And you can see you've got your factors here, which is x, in this case, minus 1, and x minus a 7. And then you can easily get your x value is equal to 1, and also x is equal to 7. So yeah, and that is another way of solving that equation. Yeah, let's move on to part C. Now, in part C, we are told that M is the reflection of C. So M is a reflection of C. The M is not there, so it is just a reflection of C in the axis of symmetry of F. So the axis of symmetry, it is always the one line that passes through the turning point. So this is the, remember the line x is equal to, remember that was a 4 from here. We calculated this turning point. So it's always the x coordinate of the turning point. So that will be a 4, the line 4. So we are told that it is a reflection of C in the axis of symmetry of F. So in this axis of symmetry, find the coordinates of M. So which means M might be somewhere there. So we want to find M. So if it is an axis of symmetry, what it means, it is if it is reflected in the axis of symmetry. So what it means is that when you find this coordinate, it will be on the same line as C. So you know what? You have to find your y coordinate here of the intercept. So to find the y coordinate, which is the y-intercept of F, you let what? X is equal to 0. Remember to get the coordinate of C first. So y-intercept, we let x is equal to 0. So f of x will be equal to, so x is equal to 0. So f of x will be equal to here as 0 minus 4 bracket squared minus 9, and that gives us a 16 minus a 9, and that will be equal to a 7. So the value of y here is equal to 7. Now, once we get the value of y as 7 here, we can actually determine what the x coordinate of this point will be using this line x is equal to 4. So we know that to move from this point to this point, it's actually a 4 units. Then from there to the m value, because it should be a reflection, it should be another 4 units. So which means the x coordinate here of m should be 8, because this is a half and a half there, so that should give us an 8. So the x coordinate of m should be 8. So x is equal to 8. So then after you get your m, your x is equal to 8, then you've got your y already. So then the coordinates will be 8 and 7. Okay, so some may prefer to use another method whereby you can take the 7 that you've gotten here. So the 7 for the y coordinate, then you put it back into the equation to get x. So then you can now say 7 is equal to, in a bracket, x minus 4 bracket squared minus a 9. So then you can expand that. That would be 7 is equal to x squared minus 8x, then plus a 7. So if you throw that 7 this side, that would be 0 is equal to x squared minus 8x. And you can see that 0 is equal to x bracket x minus 8. Then x is equal to 0, which makes sense for this coordinate here. And also x is equal to 8. Yeah, once again, we have got our coordinates 8 and 7. Now, let's move on to part D. Now, for part D, we are told to determine the equation of G, that is the straight line, in the form y is equal to mx plus c. So one thing that you need to know is that DE, the line DE, is parallel to the y-axis. So what you just need for the straight line, you just need 2 coordinates. So we already have the coordinates that we calculated there, and we can get the coordinates here. Remember, we said that x coordinate of the turning point was a 4. So this is just 4 and 0. So we have got the coordinate 7 and also the coordinate D. So then we can just find our gradient for the straight line. So m, remember, is equal to y2 minus y1 divided by x2 minus x1. So in this case, that will be equal to, so there that will be a 7 minus so this is 0, 7, so it's 7 minus 0, then divided by a 0 for the x coordinate minus a 4. So then the the gradient will be equal to 7 over 4, negative 7 over 4. So once you have got the gradient, then you can just say the gradient of a straight line is equal to y is equal to mx plus a c. And we know our m and we also know our c already. There's no need to calculate because it's the y-intercept. So then y is equal to negative 7 over 4x, then plus a 7. So that will be the equation of the line y is line g in the form y is equal to mx plus c. Moving on to part E. Now in part E, we are asked to write down the equation of the inverse of g in the form y is equal to. So we know that the equation of g we calculated previously, that was y is equal to negative 7 over 4x plus a 7. So now to do the inverse, we just swap y and x around, then we make y the subject. So the y becomes x, so x is equal to negative 7 divided by 4, y plus a 7. Then we just make y the subject. So then that becomes x minus 7 is equal to negative 7 over 4 y. Then we just multiply both everywhere by 4 to just get rid of the fraction. So 4x minus 7, 7 times minus 7 times 4 is equal to negative 7y. So then 4x is minus 28 is equal to negative 7y. Then we just divide by negative 7. Then negative 4 over 7x minus, so then that will be plus, because negative 28 divided by 7 is then plus 4 is equal to y. So then the equation of the inverse of g will be y is equal to negative 4 over 7 plus a 4. And that is how you do the inverse of that graph. Let me know what you think. Now, moving on to the last part of the question, which says, for which values of x? So here, every time when they say for which values of x, know that you're dealing with the x-axis. Will x multiplied by a function of x be less than or equal to 0? Right, I've seen students struggling with this, but this is quite easy. What it means is that the x coordinate, then if you multiply that by the function of x, that thing must be a negative. So it should be a negative, because that's what it means, less than 0. So for you to get a negative number, remember you have to multiply either a negative plus times a positive, or a positive times a negative. So we check on the x-axis and also on the function of x, where it's positive and a negative, where it is different. So that one has to be positive and the other one has to be negative. So yeah, let's get to the graph. Now, let's check from A here going this way, from A. So the values of A from here going that to 0, they are positive. And you can see also the graph is also positive this side. So then that will be a positive times a positive. That gives us a positive. So we are not interested in that part. Now we check here from 0. Now from 0 going all the way, it's a negative. And you can see the graph is going to continuously be negative. So we are interested in that part because a negative times a positive, that gives us a negative. So we can say now x is here less than or equal to 0. That we're interested in that part. Now let's check from this part here from A to D. Now from A to D, x is positive and the graph is negative. And we can actually check to B, and you can say from A to B, x is positive and the graph is negative. So we are interested in that part. So we can say also x is greater than or equal to, because in the question they are saying equal to. Greater than or equal to from the coordinate of A, that was 1, and less than or equal to 7. And that is how you do such a question. So in the same manner, they can ask you maybe g times f of x is less than 0. So you do exactly the same thing, where the graph of g will be positive and the other one will be negative. Then you can find your answer doing that way. So yeah, this is how you tackle a parabola in the straight line. Now moving on to the next section, we will be talking about the exponential function. Right, I hope the question on the parabola in the straight line was fantastic, and it has also enabled your understanding. Now moving on to the exponential function. So the first question, so we have got an exponential function, g of x is equal to a to the power of x, and the coordinate s, 2 and 9, and also t as the y-intercept. Now, first question, we are asked to write down the coordinates of t. So when you check your t is a y-intercept. So that is y-intercept. So if you remember very well, for the y-intercept, we let x is equal to 0. So we just write down our equation. G of x is equal to a to the power of x. Then remember at y-intercept, x is 0. So g of x will be equal to a to the power of 0. And if you remember very well, any number raised to the power 0 from laws of indices is equal to 1. So then the g of x will be equal to 1. So the coordinates of the point T here will be a 1. So that will be 0 and 1. And that is how you do the coordinates of the point T. Now, moving on to the next question, part B. Calculate the value of A. So every time you are asked to calculate a value of on the equation or a function, or be it a parabola or hyperbola, or even now on a straight line, or even on this exponential function, when you're asked to find an unknown variable, all the times you have to use a point on the graph, on that graph that you are asked. So in this case, we actually have 2 points, but in this case, we can't use 0, 1, because then our A would disappear. So we'll use the point 2 and 9. So using the point 2 and 9, we can say now, remember again, g of x is equal to a to the power of x. Then the g of x, in this case, that will be the y value. So y is equal to a to the power of x. Then the y value, it's 9. So 9 is equal to a to the power of what? The value of x here, it's a 2. So now we just have to make either the bases the same or the powers the same to solve the equations, exponential equations. So in this case, that becomes 3 squared is equal to a to the power of 2. So the powers are the same. So then, which means a is equal to 3. We just drop the powers. So it is the same when you're actually solving for a power. So if the bases are the same, you can drop the bases and you can be left with the powers as well. Right, this is how you solve that. Now, moving on to part C, the graph of h, it's not there, is obtained by reflecting g in the y-axis. So we are going to reflect this graph in the y-axis. So this is our mirror line. We're going to reflect it in the y-axis. Now write down the equation of g. Now, if you are reflecting a graph in the y-axis, what you are changing the x value to be a negative. So in this case, you have our function g of x is equal to a to the power of x. So if you reflect in the y-axis, only the x values becomes negative. So g of x in this case will become not actually g of x, because it is the h of x now that we are looking for. So then the h of x will be equal to, so remember we said in the y-axis, the x becomes negative. Wherever there's an x, you just put a negative. So in this case, that will be a to the power negative x. And that will be your equation. So let's suppose they had said it's a reflection in the x-axis. So then in the x-axis, the whole g of x becomes negative. Then in this case, g of x will be equal to negative times the whole thing after the bracket, after the equal sign. That will be negative a to the power of x. So that will be the reflection in the x-axis. But now in the y-axis, the equation will just be h of x is equal to a to the power negative x. Now, moving on to the next question, part D. Now, for part D, we are asked to write down the values of x for which log 3x is greater than 0 and less than 1. Where is the log 3x coming from? Now, if you were dealing with an exponential function, you already have to know that the inverse of an exponential function, it's always a log. So let's say, for instance, if you are given a function, y is equal to a to the power of x, like that, then automatically this can be rewritten in the form of logarithms as, so the a still remains the base here. So that will be log ay. So log ay is equal to x. So a log is always an inverse of the exponent. So in this case, if we are asked to find the inverse, so you would change now your y and x. So that will be log ax is equal to y. So that is what you apply. So with this in mind, let's find the inverse. Let's see. So we had a function y is equal to, in this case, g of x, y is equal to, it was a is 3 to the power of x. So remember, this can be rewritten in the logarithmic form. So we can swap around before we do the inverse. That will be x is equal to 3 to the power of y. And this can be changed with the logarithm to get the inverse. So that will be now log, remember 3 remains the best, 3, then x is equal to y. So that's where the log 3x is coming from. Now we know that log 3x is actually an inverse. So remember, to get an inverse is always a reflection in the line y is equal to x. So if you have got your line y is equal to x, you don't need to struggle to plot the graph of log 3x. So it's always an inverse. So it is going to be a graph that looks like this one. So it goes, just a moment, let me just rewrite that. So then it will be this kind of a graph that goes through 1, and it nearly looks the same like that pink graph on top. Then we have got here again the point t that is reflected, that will be a 1, and it also continues to be an asymptote along the y-axis. Now we are asked for the values where log 3x is greater than 0. So we check it greater than 0, so that is like your y value. So it is greater than 0, so that will be at this point here, but less than 1. So it is less than 1 at this point. So this point here, this part here, that is the one that we are asked. So we want to find the x values which are responsible for this output. So we are just interested with that part and also here. So we can see already that x should be greater than 0, because that is part of x. It is x, that is 0 point, so it's a 0, 0. So x is already greater than 0. But what will be that x value at here at 1? So that we go this side, then we put it that side. So we want to find what will be the x value at 1. What will be that x value? So to do that, now y is 1, because we see there. So 1 is equal to log 3x. So what is that x value that we say log? Remember, log 3 will give us 1. But if we don't know that, we can work backwards to exponential. Remember, using that, we say that if you have got a function y is equal to a to the power of x, this can be written in the logarithms as what? Log a y is equal to x. So now we can rewrite that whole thing using the exponent. So then 3 remains the best. So 3 to the power 1 is equal to x. So that will be a 3. Now we know that x is greater than 0, and also it has to be less than 3. X is greater than 0, and x has to be less than 3. So we can rewrite this thing, x is greater than 0 and x is less than 3. So those will be the values at which log 3x is greater than 0 and less than 1. So this is how you solve the exponential function. So now moving on to the last question. Now this is one of the questions that I love the most. The hyperbola, they are actually very easy. So before we attempt them, you need to remember the general equation of hyperbola, which is y is equal to a divided by x minus p plus a cube. Remember, we say that p and q are the asymptotes. So p is the vertical asymptote, which is x is equal to p, the equation of the vertical asymptote. So that is the vertical asymptote. Then q, that will be y is equal to q, that will be your horizontal asymptote. This is quite easy. So then you can relate this general equation to this general equation here. Then you can be able to answer whatever questions you are asked. Now, moving to the questions, we are given f of x is equal to 1 over x plus 2 plus 3. Then we are asked the first point, determine the equations of the asymptotes of f. It's just easy. Remember, if they are equations, you don't state a value. You have to say x is equal to y is equal to, otherwise you'll be penalized. So in this case, you can see that that is x plus 2. So, but general equation has got a negative, so which means actually x is equal to a negative 2. So if you put a negative 2 here, then it gives you a positive 2. So x is equal to negative 2. That is the vertical asymptote. And the horizontal asymptote, that will be just plus a 3. This one does not matter the sign. So then y will be equal to positive 3. Okay, in simpler terms, if you have got x as positive, then know the asymptote is negative. And if you have got x as negative, then the asymptote is positive. X values, they always swap around. The negative becomes positive and the positive becomes negative. So these are the equations of the asymptotes. Now, in part B, we're asked to write down the y-intercept of f. So remember now, for the y-intercept, we let x is 0. So then y will be equal to 1 over 0 plus 2, then plus a 3. And that gives us a 3.5. So that is your y-intercept, the 3.5. And in part C, we are asked to calculate the x-intercept of f. So the x-intercept of that is easy. We let y is 0. So for the x-intercept, y is 0. So x-intercept, y is equal to 0. So then we say 0 is equal to 1 over x plus 2, then plus a 3. Then we just throw the 3 that side. That becomes negative 3 is equal to 1 over x plus 2. And we cross multiply. That will be negative 3x minus 6 is equal to 1. Then that becomes negative 3x is equal to, then that becomes a plus, that becomes a 7. So x is equal to negative 7 over 3. So that will be the x-intercept. Now, moving on to part D. Now, in part D, we are asked to sketch the graph of f, clearly label all intercepts with the axis and any asymptotes. So that is exactly what we have been doing at part A, B, and C. So we just go ahead and draw our Cartesian plan. So that is the y-axis and the x-axis first. So we've got our x-axis and the y-axis and a 0. Now, the other thing that you need to show first of all before you sketch the graph are your asymptotes. So go ahead and draw the asymptotes. So in this case, we've got x is equal to negative 2. Remember, that is the vertical asymptote. So we need to clearly state that. So that will be here a negative 2. Then, and y is equal to 3. Y is equal to positive 3. That will be right there. Now, once you have all this, sometimes when you look at the value of your a, it's a positive. You can see already when it's positive, the graph will be in that part and also in this part. But let's look at the cuts first. So remember we said now the y-intercept was 3.5. So the y-intercept was 3.5. 3.5 is just above 3 somewhere there. So it means your graph is going to cut there. And also the x-intercept was negative 7 over 3. So negative 7 over 3 is just after this side. So it is there. So then you can see already that your graph will be at this point here and also at this point. And there you go. Then you have got your sketch. All the points are shown clearly. The asymptotes, the y-cut, and also the x-cut. And that is how you sketch this graph. So if this value of a was a negative, then you would expect your graph to be there and there. So this is how you answer functions. Now, with the other thing that you can be asked, they can ask you to determine the equation of the axis of symmetry of this graph, the hyperbola. So you should know that the axis of symmetry, so this is the axis of symmetry. So there are two axes of symmetry and this other line as well. So for the axis of symmetry of the hyperbola, you should always know that this line has got a gradient always equal to 1. And this other line, we have a gradient always equal to negative 1. And they will always pass through at the point of intersection of the two asymptotes. So in this case, they will pass through the point here, negative 2 and 3. So then with that in mind, then we can be able to determine the equation. So for the M1 line, we can say now y is equal to mx plus ac. And we know what our m is. So y is equal to m is 1. So that will be 1x, so 1x was just x plus ac. Then we use the coordinates, the asymptotes, that point negative 2 and 3 to get c. So here the y is 3, so 3 is equal to negative 2 plus c, then c is equal to 5. So then the equation of the axis of symmetry with the gradient 1 will be y is equal to x plus 5. Then for the m with negative 1, you do exactly the same thing. In this case, your m is negative 1. So negative x then plus a c. You use again the same points, negative 2 and 3, because that will be a common point for the both axes of symmetry. So then that will be your y is here, a 3 is equal to the negative bracket, negative 2 bracket plus a c. Then you can see here your c will be equal to, post that will be a negative, so that will be 1. So then the equation will be y is equal to negative x plus 1. So this is how you determine the equations of the axis of symmetry. Then the other thing that you can be asked are the domain and the range. So for the domain and range of the hyperbola, you always say for the domain, remember these are x values, you always say x is an element of all real numbers. So you can see it will take up all the x values, but it won't take up the vertical asymptote. So x will not be equal to negative 2. Then for the range as well, y will be also an element of all real numbers. You can see it takes up all the y values, but y cannot be the horizontal asymptote 3. So that is the domain and range. And this is how you solve functions. And I wish you all the best in your exams, tests, or exercises. It's a bye for now.